Thank you very much. Okay, thank you very much. It's a nice introduction, and I'm glad here again. So this is actually my third time to visit Christchurch. And, this time, the reason why I'm here is, the Osaka University, actually the Graduate School of Information Science is opening up the master's degree course and PhD course, actually master's degree course solely taught in English, so that we would like to recruit good students from over all the world, including here New Zealand, and also that we are having what we call Human Innovation PhD program. This is a kind of government-sponsored PhD program. And if you apply for that and select it, it's actually 5 years program, means that 2 years master's degree and 3 years PhD program. I think that you will get some sponsorship from the government, and also that along with the ordinary graduate course, we will prepare a special program. And and the problem of the Japanese government is that they first call for proposals for every university in Japan, and we write proposals, and then they decide which university is going to have this grant almost at the end of the fiscal year. Means that this is our first year, and our graduate school has been accepted for this program probably sometime in December, and the end of the fiscal year is March, so that all the budget allocated for this year has to be spent by the end of this coming Sunday. That's why that I'm here to explain about the program. So that's the main reason for me to come here. But actually, I and HitLab New Zealand, or Mark Billinghurst, who is the director currently, the lab, has a long communication, more than 20 years, because I think that we first met him at the IEEE conference, or the VRA conference, which was held in Washington, D.C., and I think that at the time he was doing his PhD with the University of Washington, with Tom Furness, of course. And since then, I think that, and also that I was at that time with ATR, and Mark has a strong connection with ATR, but that something happened after I left ATR. So here's my introduction. So I finished my PhD at Osaka University, but after that I joined ATR for 7 years, and after that I moved to the Nara Institute of Science and Technology, which is Professor Hirokazu Kato is currently working with. And since 2001, I came back to Osaka University and had my own research lab. And actually, there are so many affiliates. It's a crazy thing. I don't like this. But actually, currently, my main job is that Professor Information Education Division, Cyber Media Center, Osaka University. Cyber Media Center is a kind of computation center, where we provide supercomputing function or high-performance computing infrastructure campus-wide, and also the part of that is being used by nationwide. And Information Education Division is the kind of division which is taking care of the on-campus computing facility for education, including lab computer terminal-equipped classrooms, and also course management systems and lecture video capturing systems. These kind of things are being operated within this division. But since this is a kind of service center, we cannot recruit students. So that I'm also at the same time professor at Integrated Media Environment Lab, Department of Information System, Graduate School of Information Science and Technology. That's a graduate school, and which has 7 departments at this moment, but I belong to this Information Systems Engineering. And each, I think, department has 4 to 5 research labs. Research lab in Japan typically consists of 1 full professor, 1 associate professor, and maybe 1 assistant professor, along with postdocs and PhD candidates and master's course students. So, and I think that so these two positions is a normal position, and usually that's it. But somehow I have involved in so many things. Currently, I'm vice director of Cyber Media Center. I used to be director for 4 years, and at the time I was too busy and had no time to research. So that my term period ended a year and a half, 6 months ago. So I thought that I can come back to do my own researches, but since then I have so many other things listed here. So the deputy head of creative unit, Osaka University. What is creative unit? That is the this unit is in charge of maintaining Osaka University official website and also campus digital signage system. That's what we call OPAS. And this unit consists of 2 academic staffs, 2 designers and 2 editors in English. And actually, these are the, if you have visited the Osaka University's website, it's a completely bilingual. Means that everything written in Japanese can be shown in English by selecting the upper right corner of the language. Typical things, what happens if you click English, that brings you top page of the same site, and sometimes the contents is differs. But in case of Osaka University, I think that the literal translation is being provided by the English editors, so that it's a good resource for you to study Japanese language. Because if you'd like to see how to translate these academic terms in Japanese, you just click the Japanese button here, and then you can see the translation in Japanese. Of course, the Japanese is original, so the English is translation, but anyway. At the same time, the creative unit designs these kind of logos. So that I think it's sometimes working with these designers is very nice for me to design human-computer interaction also. So that I start thinking that the designing is very important for doing research in human-computer interaction. And so this is fun, but the other things is a little bit complicated. So at the same time, since I was heavily involved in information, by the way, Infomedia Education Division is we call IME, and Integrated Media Environment is also stands for IME. So that anyway, we call this is IME division, and then that means both Cyber Media Center division and also the research lab in Graduate School of Information Science and Technology. But and along with that, recently I'm a little bit involved in faculty development things, like I'm a manager of Department of Academic Planning and Development, Center for Liberal Arts and Sciences. And also that I'm also the head of one of the division in that is Teaching and Learning Support Division. So, well, this is closely related because we are promoting the using ICT technology for education. And in order to do so, the Cyber Media Center itself cannot complete the mission because we can provide facilities, but we cannot ask faculties, please use this, or you have to use this. So we have to do some strategic way of heavily involved in with such a department that is the Center for Liberal Arts and Sciences, and they start doing a lot of faculty development things, how to use lecture capture system for your classroom effectively, or how to use course management system, or how to use maybe in future AR, augmented reality technology, or virtual reality technology for education. So that's why that I'm a little bit involved in these centers. Okay, that's what I'm doing here, and of course from academic career I'm a member of IEEE, ACM, and also comparable Japanese Society, Information Processing Society of Japan, or Institute of Electrical Information and Communication Engineers in Japan, and also Virtual Reality Society of Japan and Human Interface Society in Japan. And currently I'm president of Human Interface Society Japan. That consists of maybe 1,300 members there. And along with that, I'm somehow in charge of open course. You're familiar with the OpenCourseware? That is the initiated by the MIT, and they put everything on website, including course materials, videos, and things. And Osaka University has also OpenCourseware site under the URL of ocw.osaka-u.ac.jp, and I'm in charge of running that site. because probably partially because I'm involved in a course management system, because the contents are already uploaded to course management system, and we select some of the good courses from there and publish it as open courseware. And somehow I'm currently the president of Japan Open Courseware Consortium and board member of the Open Courseware Consortium. It's a global consortium, consists of more than 250 or 300 universities worldwide. Okay, that's the probably I think the job function I'm related to. And the other things is I'm paragliding pilot. I do paragliding since 2001. So that when last time I visited New Zealand, I flew in Christchurch, where they call Castle Rock in Christchurch. They did paragliding there. This time, I have no time to do so. I think so. And also, I'm certified tandem pilot since last year, so that I can fly tandem with my wife anyway. So next time when I come back here with my wife, we will fly together, I hope. Okay, that's a too long introduction anyway. So these are the things. That's the Center for Liberal Arts and Sciences. But anyway, so let's look at. So I think for your interest, I think you're very much interested in what we are doing there in Japan. And I think that you had already some Japanese visitors from Osaka University. Actually, one of my students also visited here 3 years ago. His name was Umakatsu or Atsushi. You may not, Atsushi. You may remember him 2 years ago. I don't know. And anyway, so IME lab, or my lab, consists of myself, and also the Kiyoshi Kiyokawa, and Susumu Date, and Atsushi Nakazawa, and Tomohiro Mashita. Typically, I think that usually such a research lab consists of 2 or 3 faculties, but somehow we have 5 of these. That's not fortunately or unfortunately, because you know that. Anyway, and it's going to change from this April, and Professor Date moved to different laboratory, and Professor Nakazawa will move to Kyoto University, so that we will be recruiting 2 more positions. But actually, it's a term, a position for 3 years term, and of course, it's open to non-Japanese researchers too. If you're interested in coming to Japan just for 3 years, you're welcome, and just contact me, and I will give you a detail. And actually, we have currently students from 6 countries, including Japan. Recently, I think that I'm not sure about the New Zealand, but in Japan, I think at this moment, we have 2 PhD candidates. One is Japanese, and the other is from Greek. And we have 2 research students who is going to be PhD candidates from next year. But one of them is from United States. The other is from Vietnam. So it's quite international lab. And okay, and our research. So I think I don't have to tell you this. I'm sure. Osaka University is located in Osaka. That is the western part of the Japan. Central west, I should say. But it's still in Honshu, or main island. And this is where the Tokyo is. And we are located on Toyonaka campus. Osaka University has 3 campuses. One is Toyonaka. Both Toyonaka, Suita, and Mino campuses, northern suburb of Osaka, central Osaka. And it takes about 30 minutes by train ride from central Osaka, maybe 20 or 30. And Cyber Media Center itself is located in both campuses, but my office is located in Toyonaka campus. And this is building, this is a picture of the building. I think this was built 2002. So it's a relatively new, just 10 years old building. And but before that, as I told you, I was with ATL, and first research work I did there was a virtual space teleconferencing system. And you might see in this video, I'm not sure, probably most of you maybe some of you may not born in 92, or I don't know. But this looks like this. This looks like this.
Good afternoon. Hello.
So this is a kind of teleconferencing system. Instead of using real video camera, but using computer-generated graphics, which replicates the participants the other side, so that we can have a complete 3D image from both sides. Actually, this is not pure bidirectional, but this avatar is being controlled by real human beings wearing lots of sensors at that time. And this image was being generated the SGI Silicon Galaxy machine, which cost more than $1 million or something like that, and size of the more than the refrigerator. And so
the sculpture I talked about the other day. Oh yes, I want to see it from different angles. Could you please turn it a little? Like this? May I have a closer look? Of course. Go ahead and hold it. Thank you. This is something. Let's see if I can smash it. Hey! Don't play with it like that. I'm sorry, but it's just some data stored in a computer. There's nothing to break. I know, but you scared me. I think I should put this somewhere you can't reach.
okay, so actually, that was myself 20 years before, and actually, so you can see that how ATL was sufficient in fund, because that computer cost more than $1 million, but being thoroughly used for as a personal computer like way of producing this research results. But since then, I moved to the Nara Institute of Science. In 1994, I moved to Nara Institute of Science and Technology, and still keep doing the collaborative research in VR environment or the other AR environment. But currently, the idea has been quite expanding rapidly, because we have 5 faculty there, and so that some of the work is related to wearable computing or context awareness of the mobile devices or mobile device interactions, or tabletop displays and multi-touch interaction, or there are so many different kind of things. So I can't explain complete things, entire the research topics here, but I would like to introduce some of the research topics we are working on recently. And so the basic idea is, as we say that our lab is a kind of integrated media lab, it's a kind of multimedia, but we would like to, when we easily say that multimedia is a kind of multiple independent media is being presented to the user, but our goal is to combine each media in a meaningful way, and also that give some interaction between these medias. And that's the idea. But at the same time, well, typically in Japanese university, the students come to lab when they became the senior year of the university. That's 4th year. And they do a 6-month project, or maybe 6 to 7-month project for their graduation thesis. And they do some project there. And after that, some of them continue for master's degree for 2 more years. And some of them keep staying in the same lab and doing same things, or related research topics for 2 more years. But some of them switch lab and visit different lab and do their master's thesis for 2 years. And after that, if they are interested in staying in university, they will stay 3 more years for PhD program. And actually, recently, most of them would like to go to industry, especially my research lab. They used to want to go to game industry like Nintendo or Sony, computer entertainment kind of things. But some of them also goes to other electrical engineering company like NEC or the Sharp or Fujitsu kind of things. Okay, so, and the policy of my lab is that we let these students to choose their topic of project, so that it tend to get diverse, because they propose something and that looks interesting. Let's do that, and then another new research topics being studied. But anyway, that's the current situation. And well, but this one, wide view eye camera this is actually originally the idea of Professor Kiyokawa, and he was working wide view head-mounted display, projection display, and by using the same optics, I'm sorry, I don't know how to stop this. Here we go. Yeah. So it's a gaze tracking camera. Consists of, here's the camera, and this is the flat mirror, and here's the half-silvered mirror. This is a hyperboloidal half-silvered mirror, and it has a small hole here, so that this camera can directly get the picture of the user's pupil or the eye image. And at the same time, this camera also looks at the entire region of this hyperboloidal half-silvered mirror, which gives a reflection of the surroundings, the environment where this user is looking at. And since the single camera is being used, means that it's a kind of coaxial capture of the user's view and eye using and eye image. And so there's no disparities between the user's real view and the camera image, which is looking at the environment reflection. And so this shows how this is an experiment. So this is the eye image, and currently I think we are using the image-based estimation of the gaze direction, because it means that we first run the training phase and ask the user to look at he's sitting in front of the wall, and this is the projected image saying where to look at, and the user views that positions, and each eye image looking at the specific region is being stored on the computer, and then we linear interpolate the position based on the feature extraction from the images. And this green dot indicates the estimated gazing point. And as you can see, now, well, at this moment, I think the accuracy itself is around 1 degree or so, but it has a very wide, typically, I think that the typical gaze tracking camera is just has a detection range of this small, relatively narrow, like 30 degrees diagonal, because they are being mainly used for maybe where the user is interested in on computer screen or something like that. But for real environment, a much wider angle of view detection is necessary. And in this case, I think it is more than 60 degrees in diagonal. And that's one of the research topics. And the next one is the multi-view VR interface. This has been, so this is a kind of interaction techniques in immersive virtual environment, like head-mounted display. And in this environment, the problem with this immersive virtual environment is if you are in certain position in the environment, it's sometimes if you'd like to reach out the far object located on maybe 20 meters beyond from you, or maybe located behind the wall. Sorry. We put multiple viewports. It's a kind of windows looking into that environment. as being shown here. This frame shows the view from different viewpoint in the virtual environment. And if one is looking into that, or in this case, sorry about that. This video is very too concise, but so this is a kind of fixed viewport. But when you look at these circular things, this is the dynamic viewport. It's a what we call hand reference frame. And the frame is expanded to track the user's hand. So in this situation, the user's hand is being reached out in far away by and brings back the view around that place. And also that in this case, the view frame can be manipulated by manipulating the camera view object. The left one is camera view object, and this is the right frame is the view from that position. So by manipulating, we can see that the view changes. And also that there are several ways of like the initial position of the frame can be set by several methods, but in this case, the lay casting method and world of miniature is being used. And so that's the VR interactions. And well, sometimes we want to use natural gestures for such a VR environment, especially in an immersive environment. And this one is the pointing recognition system from single camera image, single camera videos. So in this case, first the training phase, and this user is being asked, he's being asked to point at there's a small target, and he is being asked to follow that target by using his arm, and the multiple images being collected like this, and by extracting features and analyzing, then I'm sorry. As you can see that it's a sample applications, but he's controlling this small soccer ball, and the player is following that. And this is one of the projects done by our probably 4th grade students. And well, instead of having the frames in immersive virtual environment, well, if it is cable-like immersive virtual environment, it is possible to bring in some devices into the environment. And in this case, the PDA-based magic lenses, and so that maybe this is 3 years old, so that I think this research was before iPad was introduced. If the iPad was introduced at that time, probably we will bring into the iPad into there. But at this time, we just brought in some PDA inside, and this PDA can be used to choose object to manipulate, or also PDA can be used to give a different view of an object. In this case, first here he's selecting the object to manipulate, and after that he is translating the object position. But in this case, I think here's the object. I'm not sure, this is a surface rendered, but actually in here it has a wireframe image of the object, so that this works as kind of magic lenses. And instead of realizing these kind of things in software environment, we provide different display system, and by holding that and placing on top of that, he can see the inside of the object, or with the object with a different way rendering method, like a wireframe rendering or the volume rendering, and that's it. And here comes the wide area 3D reconstructions. But when this was originally initiated by the hint of how to do disaster recoveries, because when we do happen to meet the situation where the disasters happens, for example, all the building or structures which we used to have plan of these buildings are destroyed, so that means it's deformed. so that we have to reconstruct the planar form again from the existing debris or something kind of environment. And this is the initial study, but by setting this is the one-dimensional laser range sensors. So it measures the distances where the laser ray is being projected. And this is just 1D, but and typically used for robot control, so that robot can detect the distance to the obstacles. But the problems. But here we have small 2D cameras, and this camera also looks at the object being measured, and also track the future point of the object. So by combining the 3D location recovery system like PTAM or the kind of things, we can now reconstruct 3D environment. So here, what's happening here is that the students is pushing some cart along the street, and this is the camera image captured by the camera on the cart. This is the reconstructed 3D point of crowd. This is 1D scan data. So this is the reconstructed 3D environment. But at this time, you may know that this is only point clouds. So that after that, although I don't have a video, but we do a kind of segmentations and define this is building or this is tree, and then after that we can match with the pre-existing data, so that which part has been destroyed or modified or it changed its shape, and then we will be able to use that data for a kind of robot navigation to do a kind of some disaster recovery or things like that. Okay, and here here's the first video I did explain about the wide-angle view head-mount eye trackers, but here the same or quite similar optics can be used for wide-view head-mounted display using head-mounted display. And this is actually the projection-based head-mounted display, and that consists of here's a mirror, and here's a small projector is located on here, and its project image on top of this half-silvered mirror, and then reflects it and goes out, and the ray goes out from the ray, which is coaxial with his eye point, so that the projector is located to the equivalent position of his eye, so that this projector do not have any parallax between the eyesight and then we put the reflective screen in front of the user, and this screen should be quite wide enough, because since this hyperboloidal mirror the image, so that it's going to spread quite a lot. And then so he can see through these retroreflective images from this half-silvered mirror, and it's going to be a quite wide-angle view. But the problem here is that since we use this kind of non-linear mirrors, the projected image is going to be distorted by the mirror. So what actually we do is we pre-compensate the distortion by using the non-linear rendering like this, so that this is the projected image. And I'm sorry, this is this is not visible at all, but this is projected, observed images. So as you can see that these lines are being curved, but when after that projected, I'm sorry. I think that probably you can see that some linear lines here, so that's being pre-compensated, and you can see that the users can see less distorted image through the half-silvered mirror. But of course, one of the drawbacks of this system is that I'm sorry. We have to set up very wide retroreflective. It's quite difficult to pronounce. Retroreflective screens, and so the second version will show up here, and the this one is the newer version, and what we have here is the kind of what we call transparent retroreflective screens, which consists of very thin slit retroreflective devices, so that actually what he will see is the projected image is being the image from the projector is being projected onto this screen and then goes back into the eyes. And since this is transparent, you can also see the outside environment. So this can be used a kind of wide range optical see-through head-mount AR head-mount displays. And so, but still, the problem is that, so these characters are being image projected onto that screen, and these white checkerboard and these are objects residing outside of the screen. And this is the observed image. Sorry about this. So, even though we can get a wider view of field of view, the problem is that still we don't have much higher resolution projector that can be mounted on top of the HMD. So we have to wait for higher resolution head mount projector is coming out. And this is the related research, and we have evaluated the wide view HMD effectiveness by using the simulation in cave environment. Since the cave has a much wider view of the field of view, and the idea is that since we are developing the wide field of view optical see-through HMD, that can be used to put some annotating information relatively out of the scope, so that this is kind of peripheral vision. And we wanted to see if that kind of peripheral vision can be utilized by useful to give a kind of guidance when one is doing navigation through this kind of maze-like environment. Because you know that currently most of the optical see-through HMD, including Google Glasses, has smaller field of view, and it's really ruins the central vision, and it's sometimes annoying. So that if we could use peripheral vision more effectively, like that, you have to look this side. So, for example, that there's very important object is being located on this side, but and I'm looking this direction, and if we can cue some, there's information by using peripheral vision, like using this kind of wide view optical see-through head-mount display, this would be useful. But so we did this kind of simulation by using the cave-like environment and do some empirical studies. And actually the finding itself is that still the signaling using the peripheral vision is very useful. But the problem is that compared to the direct instruction being displayed in front of him, it's less effective. So that it's a kind of trade-off things we found, and probably we should use So if things are properly designed, the peripheral vision can be used very effectively, we think. And okay, there are too many videos I have. And the other things is that this is research done Professor Nakazawa and his colleague Christian Nitzke from Germany. This is the display camera calibration from eye reflection. So currently, a typical laptop computer has small camera on top of it, even MacBook Pro or the other kind. Most of the computer has small camera here, so that and there are two characteristics. So that by using these cameras, if this camera's resolution is high enough to get an image of the display, which is being reflected on one's pupil eye surfaces, then we can reconstruct the position relationship between these cameras and eye and display. And sometimes that can be used for head tracking, but sometimes this can be used for calibrating the display and camera. And that's a really theoretical thing. And after that, if we could calibrate the position of the eye and the camera and display, then we can also do kind of gaze reconstruction algorithm by just using these cameras, and the system can monitor where I'm looking at without with very simple calculations, and that's it. And well, here the other things, AR-related things, is that we are working on reconstruction of and modeling and authoring in AR environment, and this object is now being selected, and the 3D replica is being posted here, and he's authoring where to move this object to move. And this has, okay, I have so many videos. This is multiple multi-touch touchpads, and this enables simultaneous use. So iPad is a kind of typical multi-touch devices, but these multi-touch touchpad is very cheap nowadays, so that if we could use two of them at the same time, we can do a kind of simultaneous bimanual operations by translating, rotating, and we did some empirical study of effectiveness of this kind of bimanual interactions. And okay, let me skip this. Okay, these are the work done in our research lab, but these are some of the recent research work. So how many of you did you attend the VR 13 this year, which is being held in Florida? But this was the VR 13 poster. It's a pinch and paste, and that's the kind of interaction technique of take the texture from real environment and put that into virtual object. A little bit. Well, actually, this video is just describing the interaction from virtual object, so that he's take away the texture from this chair and put that onto this table. But the algorithm we are using is the kind of detect the region of the texture from not only virtual object but but also at the same time the real object, and put that onto the virtual table. And this work is done by our research student from United States, Jason Orlowski, and he's working on dynamic text management. This is also something related to the optical see-through or video see-through head-mount displays. But if one would like to see his maybe schedule or email or whatever information, it's not annotation-like information. If it is going to be annotations like, say this is the display of the Apple computer, then the annotation stays with this object. But if the information to be displayed is kind of a message from his friends or the email from his colleague or what it was his schedule for this afternoon, it have to be placed anywhere which is easily recognized and easily readable, so that when we look at the real environment, for example, if this text is being displayed here, where the background is very has a dynamic brightness differences, this text is not readable, or it's not difficult to read, to be read. So in this system, this green or this dot displays the background uniformity calculated from the camera images, which takes the image of the background and suggests that here is less contrast change or color change, and this is the candidate area where the text should be put in this case. And for example, it's too fast, sorry about that. Maybe this time this areas. So this is the work we have presented at the Intelligent User Interface this year, and somehow, and fortunately, we got Best Paper Award. And the other application of the AR is that sometimes this is the assembly assistance, and in this case, left hand is the real object, and the system, by using Kinect and a video camera, the system recognizes whether the user is correctly assembling these objects or not. And so every time when the user touch one parts here, it's being automatically recognized, and the model is being also constructed here. And if we could correctly recognize, then this can be used for assembly assistance. And in this case, the system is detected that so far the shape has been made to this step, and then the guidance, what to attach next, is being displayed as an animation. And he's attaching, and now system detected that this yellow brick has been added, so that the animation shows that 2 more red bricks has to be attached here, and it's being attached. The next step is being here, and in this time, he made a mistake and put things in different position. And then the red one is coming here, and this red one is blinking. This brick is blinking since this is assembled in a wrong manner, so that this has to be removed, and also still showing, this has to be removed and placed in the right position, like this. So, okay, that's the. I spent too many videos, but that's what we are doing currently, and I would like to explain. This is the main purpose I came here, so I have to explain about this. So, so Humanware Innovation Program is a kind of a new graduate PhD course that is planned to accept 20 PhD students every year for 6 years period from now on. And for this program, the Graduate School of Information Science and Technology and the Graduate School of the Life Science Technology and also Graduate School of the Engineering Science are being closely related. And if you are getting to your PhD work from these 3 graduate schools, you are qualified for apply for this Humanware Innovation Graduate Program. And once you, and there will be a selection based on your resume and the interview, so that in order to in order to get into this program, you have to first pass the entrance exam of either of these 3 graduate schools, as I mentioned. And that graduate school usually asks you to, so that's you to solve some of the paper exams written in Japanese. And that's quite hard for English-speaking students. So that we are planning to set up different entrance exam for foreign students who do not understand Japanese. The detail has not decided yet, but that will be announced sometimes in June or July this year, I hope. And that's going to be consisting of interview-based exam plus some of the paper examination in English. And once you're selected, you will typically, the school year in Japan begins from April. But for foreign students, we are thinking studying some courses beginning at the beginning of the October. And if you pass the entrance exam this summer, you will be accepted as a student from this October, coming October. And for that courses, everything is being taught in English. And also, once you, that's the typical English courses for foreign students. But once you are enrolled in that English course for foreign students, you get a qualification to apply for this Humanware PhD program. And for this Humanware PhD program, I think the exam selection is based on interviews, candidate interviews, and how much where the person is interested in this project, and also that I think that the basic idea of this project is, first of all, probably you may think, what is humanware? Well, nobody knows what humanware is, but this is kind of human-centered information processing and human-centered system design, and biology, and also that human beings is kind of we are also one of the how do I say that, biological maybe creature, means that biological information processing is quite different from computational based information processing, because everything is being done in parallel by small cells or the brain cells and nerves, whatever it is. And we can learn a lot of new method by so actually some of the research lab in Osaka universities looking into that kind of information processing in a biological way, and thinking of bringing that back to the computational processing method, so that we can produce a better algorithm to solve some problems, or probably we can provide better human-computer interaction techniques based on the biological information processing. It's a kind of, probably traditionally it was called as psychology-based or something like that, but when we look into more fine grains beyond the psychology, it's probably we sometimes have to check our brain cell processings, and we can learn from that, and we can design some interfaces. So anyone who are interested in doing research in such a way means that multidisciplinary, partly based on bioengineering results or the maybe cell-based information processings, and the other discipline is also in human interface technology lab. Well, it's a kind of human-computer interaction method for better understanding of providing a better understanding of the real environment, or or whatever it is. So if you are doing your PhD, so in short, if you are willing to do some PhD research in interdisciplinary topics, you are qualified to apply for that Humanware Innovation Program in easy way, in a sense. So that's about that. And once you are selected, as I mentioned, you will get kind of funding of kind of monthly salary, which will not so high, but still it's one of the highest ranking among the salary given to Japanese PhD candidates, and that's about the 2,500 New Zealand dollars a month. And also that if you're a foreign student, usually there is a good chance for your tuition to be waived. And also this program will have not only traditional class lectures, but also lots of project-based things, including the short-term stay in overseas research laboratory as a research internship. So you may come to Osaka University from New Zealand, stay here for a research internship in New Zealand. I don't know if that's going to happen, but you can select several places. Like we have a strong relationship with UCSD in California, United States, or some other places like National Singapore University, places like that. And so, well, that's the brief overview. And we have already selected the first year Japanese students because this program starts from this coming April. So for Japanese students, it's going to start in 3 days or something like that. And for foreign students, it's going to start from this coming October. Okay, and unfortunately, not so much detail about the international students plan is not decided yet, so that this is all what I can say at this moment. And if you have any questions, just send me email. Okay, thank you very much. Thank you very much. And also that I have no time to explain about paragliding experience, but I have YouTube channel. So you can find it out if you like.
Do you have any questions?
Probably acquainted with Haruo content. It probably was a colleague of yours in Osaka.
Yeah. Actually, I have close relations with Hirokazu Kato, but to tell you the truth, I had no. Well, when I was ATL, he was in Osaka University, and when I was in Nara Institute of Science and Technology, he was still Osaka University. But when I moved to Osaka University, maybe within 2 or 3 years, he moved to Nara Institute of Science and Technology. So we have switched, swapped. Okay, so do you have any questions?
Okay, so we do have a reservation for a table for lunch, so...
Oh, I see.
So, thank you very much. And, yeah.
Okay, thank you very much.